the foaming. Forced aeration, if it is given in the beginning of the process, it affects the microbial rate and citric acid productivity. If low aeration limits are there, it will restrict the respiratory activity of the Aspergillus niger. Strongly aerated cultures increase sporulation and thereby decrease the accumulation of citric acid. Now, chemical parameters which are used for citric acid production and maintained in the fermenter are, the main ones are the carbon, nitrogen and phosphorus. They are the type and concentration of carbon increases the yield of citric acid production. The carbon may be in the form of sucrose, glucose, fructose or galactose. Nitrogen also helps in increase of citric acid production, and it will be in the form of urea, sulfate, peptone, ammonium nitrate and malt extract. And besides that, the nitrogen which is required is around 0.1 to 0.4 grams per liter. Phosphorus in the form of phosphate is used for citric acid production. The rest of the elements or the chemical parameters which are used in the fermenter are also of equal importance, but they are trace elements like metal ions like zinc, iron, copper and magnesium. Besides that, lower alcohols like methanol, ethanol, N-propanol, isopropanol in the amount of 1 to 5% help to increase citric acid production. But these lower alcohols, if they are added in crude amount, they will help to increase the production of citric acid. But if these lower alcohols are added in a pure form, on the contrary, they will give adverse effect and they will lower down the production of citric acid. Besides that, these lower alcohols will neutralize the negative effect of metal ions produced during citric acid formation. Other compounds which are included are oils and fats in the amount 0.05% to 0.3%, and they are mostly used as anti-foaming agents. Some oils which are there will stimulate the productivity and maintenance of the fermentation process. Now, the other methods or the major methods regarding the citric acid fermentation, like the surface culture method, submerged method and solid state method, in detail will be discussed by my colleague Sanjay Parekh.
Dear students, as you know that in the citric acid fermentation, different raw materials which are used are usually based on some agrochemical waste or some agricultural waste. Now, such agricultural waste and agrochemical waste are used as a raw material in citric acid fermentations. Now, if you want to carry out a citric acid fermentations, then citric acid fermentation can be carried out by different three methods. As you can see, there are different three methods: surface culture methods, submerged fermentation methods and solid state fermentation methods. Now, among this, the surface culture method is the oldest method and it is the first method which has been practiced for citric acid fermentations. Now, in surface fermentation methods, the sterile liquid medium on which the fungal cultures, specifically Aspergillus niger, as madam has stated earlier, this is the strain which has been commercially exploited for citric acid fermentations. So, in surface fermentation method, a liquid medium, sterile liquid medium in which a surface growth is generated, where the microorganisms, specifically Aspergillus niger, is allowed to grow and without agitations. So, in without agitations, when fungal culture will grow, then usually it will form a mycelial mat. As you can see in this slide, one of the flask which contains the mycelial mat of Aspergillus niger, and the mycelial mat will grow continuously. Usually this fermentation process requires 8 to 12 days. Besides, in such glass vessels, even a shallow tray which is made up of either aluminium or stainless steel can be used, where once again a sterile medium can be filled and then such trays are stacked in aseptic rooms. Usually, as you can see in this slide, that a tray fermenters are available where you can stack the tray and the humidified air, which is of course a sterile one, is passed, and the temperature is maintained around 30 degrees centigrade, and the humidity is maintained around 70 degrees centigrade, and the air circulation is carried out, which maintains the temperature, because during fermentation process temperature will increase, so temperature should be maintained within 25 to 30 degrees centigrade temperature. And also the generation of carbon dioxide, that can be controlled by circulating the air, and the fermentation process will be accomplished within 8 to 12 days. And once the fermentation will be accomplished, then the trays are unloaded for further recovery of citric acid. Now the another method, which is the most commonly employed for citric acid fermentation, is a submerged culture method. Nowadays, whatever citric acid fermentation is carried out at industrial level, amongst them 80% of citric acid production is successfully carried out with the help of submerged culture method. Now in submerged culture method, a sterile medium is inoculated with a fungal spore, where either fungal spore, dry spore or a spore suspension can be used to inoculate a sterile medium, and then a vigorous aeration and agitation is applied. When vigorous aeration and agitation is applied, usually fungal culture will grow in the form of pellets. As you can see in these slides, such circular pellets are formed. Now here the morphology of these pellets plays a significant role in the yield of citric acid. The ideal pellets which are required is usually consist of a fluffy center and a rough surface. This, which is usually in a 1 centimeter diameter, are found to be the ideal one for citric acid fermentation. Once the spores are inoculated, then it requires 2 to 3 days for the germination of spores and the mycelial development. Then in the next 6 to 8 days, the citric acid accumulation and citric acid production is carried out. Once the citric acid production has been completed, then the whole fermenter is subjected to unloaded, and then it has been subjected, the fermentation broth is subjected for product recovery in a downstream processing that we will discuss later on. Now another method besides submerged culture method is a solid state culture methods. Before going to discuss the solid state culture method, the submerged culture method, which I have just stated earlier, in this method there are different types of submerged fermenters are used, and that can be operated on a batch mode or on a continuous mode or on a fed batch mode. The fermenters which are more commonly employed for citric acid fermentation, that includes a regular stirred tank fermenter or a tower fermenter. Now the stirred tank fermenter, which is more commonly used at industrial level, where there is a aerations and agitation is accomplished with the help of agitator, mechanical agitator, and a sparger. Spargers are more commonly employed for aeration purpose. Now whereas in tower fermenter there is no mechanical agitations, only the process of agitation is accomplished with the help of aerations, and that's why it is having one advantage, that is the complexity which is associated with the agitator can be avoided in case of tower fermenter. Of course the tower fermenters are having capacity more than the stirred tank fermenter, that is around 2 lakh liter capacity, whereas in case of submerged fermenter the capacity is ranging from 20,000 liter to 2 lakh liter. Now the last method which is more commonly used for solid state fermentation is a solid state culture method, where the material, is madam has already mentioned, there are different raw materials which are used for fermentation purpose. One of the raw material which has been mentioned earlier is cassava, bagasse, apple pomace, pineapple pomace, or even the peel of banana and a kiwi fruit. These are a kind of medium which are solid in nature or semi-solid in nature. Now if you want to say that a solid state fermentation, then in solid state fermentation such carrier material like as I said, cassava, bagasse, are impregnated with a nutrient solutions, and on the surface of this carrier material, the fungal cultures are allowed to grow. Here, as you can see in this slide, there are two figures which are nowadays, there are some commercial suppliers which provide you such aseptic rooms. The whole installation can be commercially installed, and the suppliers are there where there are a closed cabinet, and there is a provision of air circulations, there is a provision of a blower, and one can maintain the aseptic condition within this chamber. And the solid substrate, as I said, apple pomace or a pineapple pomace, such solid substrate are impregnated with a nutrient solution, and then they have been spreaded on a tray or either on a platform, and then they will be inoculated with a aspergillus spore. Here the aspergillus spore can be directly spreaded over the solid substrate medium, or the blower which has been used, in which the air can be mixed with the spore suspension and then blow it over the surface of a solid medium, and where the fungal culture will develop and will produce the citric acid. Once the fungal culture will develop, then the citric acid formation occurs. Usually the fermentation process is accomplished within 5 to 6 days. Here, in terms of duration, solid state fermentation method is having a short duration as compared to the previous two methods. But only thing is, the amount of citric acid production and the capacity of total fermenter is usually low as compared to the previous two methods. So for a small scale production of citric acid, solid state fermentation method can be employed. But if you want to carry out a citric acid fermentation at a large scale level, then one has to go for either submerged method, as nowadays industries usually follows, or one has to go for surface methods. So dear students, as you can see, this is how the solid state culture method can be used for citric acid fermentations. So once the citric acid is fermented, then the next step is to recover the citric acid from either the fermentation medium, which may be in a liquid nature, or to recover the fermentation our product from the solid substrate, if you have followed a solid substrate fermentation methods. So now we shall discuss about some downstream processings. Now downstream processing that usually aim to recover our desired product, that is citric acid, from the fermentation broth, and there are different 4 methods, as you can see from the slide, available for recovery of citric acid. First method, that is the classical method, is precipitation methods. Now in precipitation methods, as you can see in this slide, the citric acid is precipitated from the fermentation broth with the help of lime, that is calcium oxide or calcium hydrated. So when calcium oxide or calcium hydrated, or a milk of lime, by which we are commonly knowing it, so when this milk of lime is added in a fermentation broth, then it usually form a tricalcium citrate tetrahydrate. Now this tricalcium calcium citrate tetrahydrate is precipitated out, and usually this precipitation process is accomplished by maintaining a pH around 7 and keeping the temperature at 90 degrees centigrade. And once this precipitation is accomplished, then precipitated are separated out by following a filtration. So once the filtration is accomplished, then tricalcium citrate tetrahydrate precipitates are separated out. Now this tricalcium citrate tetrahydrate precipitate are then transferred into acidulator, and then in this acidulator at 50 degrees centigrade temperature, hydrogen H2SO4, that is sulfuric acid, is added, and this sulfuric acid will now break down the tricalcium citrate tetrahydrate into citric acid and a calcium sulfate, that is gypsum. So this calcium sulfate precipitate are later on taken off from the mother liquor, and now the mother liquor contains the citric acid. So this is how one can separate the citric acid from fermentation broth. But still the citric acid what we have recovered from the mother liquor or which is present in the mother liquor after removal of calcium sulfate is still contains some of the impurities, and that's why these impurities can be removed with the help of treating it with active carbon. So active carbon treatment will remove some of the color organic substances which might be present still along with the citric acid, and then after that the further removal of impurities like the residual calcium sulfate is still supposed found to be present, then it can be removed by ion exchangers. So this is how the further purification is carried out. Once the citric acid has been purified, then it has been concentrated by vacuum crystallizers, and then a crystals of citric acids are obtained. Dear students, here the crystals of citric acids which are obtained, that can be obtained in two forms. One of the form by which the citric acid is commonly marketed is citric acid monohydrate and the citric acid anhydrous form. Now in case of citric acid monohydrate form, then the crystallization, of course in a vacuum crystallizers, is carried out around 20 to 25 degree centigrade temperature. But if you want to obtain the citric acid in the form of anhydrous form, then the crystallization process is carried out more than is almost 36.5 degrees centigrade, more than 36.5 degrees centigrade. If you will follow a crystallization, then the citric acid will be available in the form of citric acid anhydrous form. So this is how the citric acid can be recovered from the fermentation broth, which is more commonly followed at industrial level, one of the classical method, that is precipitation methods. Another method which is more commonly used for citric acid fermentation is the ion exchange methods. Now in case of ion exchange methods, where the citric acid which is recovered from the fermentation medium by passing through the ion exchange resins, but this method is applicable only in case where your product